So you can see that. So we are given this signal. Okay, we are given this signal. It is a sinc signal, and we are asked to find the spectrum. Okay, find the spectrum. Actually, this is the problem you have. Okay, so so we know these things. Okay, we know these things. Okay, if we have a rectangular pulse, okay, time domain rectangular pulse, we have sinc pulse in frequency domain. Okay, like this. Okay, so if you want to evaluate, so you know that find the spectrum, you have to find the Fourier transform. Okay, so you have to find the Fourier transform here. Okay, for xt, after find the Fourier transform, you can get x omega frequency domain signal. Okay, so this is time domain signal. Okay, so you already know that. Okay, so if you want to find this frequency domain signal through our first principle method, okay, we have to do an integration. No, we have to do an integration. So here sinc pulse is there, sine omega naught t by omega naught t. So this is the sinc pulse, no? Correct? Okay. Okay, so this is the sinc pulse, no? The given sinc pulse is this. Okay. Okay. So so here also e to the power j omega minus j omega t terms is there, no? So you have to integrate this integration. So you have to solve this integration. Okay. But you can see that to evaluate this integration is hard, difficult. Okay. Sometimes you can use some tools. No, you have some mathematical tools to evaluate, to do some mathematics operation. Okay, using that, sometime you can evaluate this. Okay, but sometime this most probably this integration will not be exist. Okay, because sometime integration will not be exist. Okay, so we can't directly evaluate the Fourier transform of this sinc pulse. Okay, so that is one point. Okay, we can't evaluate. Okay, we can't evaluate the Fourier transform of sinc signal directly. Okay, we have to use other method. Okay, so using some property you can derive sometime. Okay, using Fourier transform properties you can derive this. Okay, so so you already know that. I think you can remember that we have, so you have know that, you have know this. Okay, so sinc, so rectangular pulse, for rectangular pulse, we have the Fourier transform of sinc pulse like this. Okay, so we should know this. Okay, we should know this. Okay, and we have one property called duality property. It says that, okay, so we have one property, duality. Okay, it's called duality property. It said that if we have time domain signal xt, okay, and if we know the Fourier transform of this time domain signal, that is x omega, say it is x omega. Okay, so you can see that this is a time domain signal and this is a frequency domain signal. Okay, so this is one time domain signal and this is the different another frequency domain signal. Okay, and if you have the time domain signal of this kind of signal, okay, in this form, that means that capital X omega, the omega is the independent variable here. Okay, because it is frequency domain. And if you have instead of omega, if you put t here, instead of omega, if you put t here, it will be a time domain signal, no? So if you have a time domain signal as xt, okay, so you can see that this frequency domain signal is converted as a time domain signal, okay. Then if we find the Fourier transform, okay, we will have to 5x minus omega, okay. That means we have, instead of this t, we can apply minus omega, okay, instead of this t, okay, instead of this t, we can apply, instead of this t, okay, instead of this t, we can apply minus omega, okay. Then we have x minus omega, then it is multiplied by 2 5, okay. So we have the Fourier transform. So this is called duality property, okay. So this is duality property, okay. So you can see that the Fourier transform xt is x omega, capital X omega, and if we have a capital X omega t signal, okay, and if we get the Fourier transform of that signal, we have 2 phi x minus omega simply, okay. Okay, so so you can so you maybe find that I have uploaded some uh, lesson to prove this duality property, okay. And also I have solved some problem using this duality property, okay. If you need more information, you can visit that channel, and you can watch them, okay. But here I am not going to derive it, okay. So I'm going to directly use it to evaluate our signal, okay. So for my information, you can see, you can watch those session, okay. So now we know that we have this signal, okay. Now we know that, okay, also we know that if we have a time domain signal xt, okay, if we have xt signal pulse, okay, so maybe it is minus tau to plus tau, tau 2 to plus tau 2, okay, we have, okay, we have uh, the frequency domain signal sync pulse, okay. Say this is 1, okay. So here also sync will be 1, okay, not 1, it will be tau by 2, no, tau by 2, okay. So this is tau by 2, okay. And here it is decaying like this, okay. And this point will be 2 phi by tau, and this one also 2 phi by tau, correct, okay. So you can see that this is x omega signal, okay. So we know this, okay, we already seen this, no, correct. T by tau sine omega t by tau, okay, correct. Here a is there, okay, but we have remove that a, so we have only tau sinc omega tau by 2, okay. So we have this, okay, minus 2 phi by tau plus 2 phi by tau, okay. So if you guys have any problem with this, okay, okay, I hope now you can understand, okay. We have done this, okay, but we have done this to minus tau to plus tau. Okay, we have done it from minus phi to minus tau to plus tau. Okay, with a. Okay, so we have the signal like this, no? We have the signal like this. This is a tau, okay, and this is 5 tau, and this is 5 tau, like this. Okay, so this we have a tau sinc omega tau, no? This kind of signal we have. Can you remember? When we evaluate this, we have this kind of signal, no? A tau sinc omega tau. See this. Okay. Okay. So here 2 tau is there, no? 2 is there. Sorry, 2 should be there. Yeah, 2 should be there. Okay. 2 should be there because it is 2 tau, no? Yeah, 2 should be there because this has 2a tau. Okay, because this is 2 tau. And remember, this is 2 tau. So we have 2a tau sinc omega tau. This function, no? We have. Okay. Now we reduce this tau. We remove this a. So we called it 1. Okay. So here a will remove. Okay. So we have a tau. Okay. So here we will take tau by 2 to tau by 2. That means the width is only tau. Okay. So here instead of 2 tau, we will have 1 tau. No, we will have 1 tau. Okay. So here we will have 1 tau. Sorry. Here we have 1 tau. So the amplitude is tau, not 2 tau. Okay. And you can see that here it is omega tau. Okay. At omega tau, it is 5 by tau, 5 by tau. Okay. But here we have tau by 2. Okay. So that means omega tau by 2. So here also tau by 2, tau by 2. So we have 2 5 by tau, 2 5 by tau, 2 5 by tau, 2 5 by tau. Okay. So I derive, okay. I just look at this pulse and look at this pulse and I adopt it to this pulse. Okay, that is what I have done. Okay, so you should be able to do that kind of things. Hope you understand it. Okay, so if you can't understand, just tell me. Okay, then I can take some time and explain you again. Okay, so we have this, correct? Okay, so here minus tau by 2 plus tau by 2, 1. Here also tau, 2 5 by tau, 2 5 by tau. Okay, now we have, okay, so we already know this. Okay, now we have this kind of quick time domain signal. No, we have this kind of time domain signal. That is, we have, what is our signal? This one, no? A sinc omega naught t. Okay, we have here a sinc omega naught t. Okay, now t is the independent variable here. Okay, for this signal. Okay, for this signal, what is this signal? If I write this signal, it is tau, correct? Tau sine omega naught tau. Sorry, not omega naught, omega tau, correct? Okay. So this is tau sine omega tau, correct? Did I do any mistake? I hope no, no. Okay, no. I hope it is okay. So this is definitely okay. Okay, we have evaluated this. Okay, here, here we have, you can see that here we have a vector t by 2 tau pulse. Okay, and we have this sync pulse. We have 2a tau sync. Okay, sync uh, omega tau. We have this. Okay, so we have this. Okay, now, yeah, we have this. Okay, correct. So now our signal is this async omega t. Okay, async omega t. So we have here, okay. So you have omega tau by 2 here. Okay, correct, because this is tau by 2. Okay, uh, so uh, so this is not our form, no. Our signal should be in a sine omega naught t. Okay, a not a sine omega naught t, correct. Okay, I hope you will get confused, so I will done it again. I will write it again. Okay, so first we have signal a rectangle t by 2 tau. Okay, this is our signal, correct. So our signal is like this. Okay, this is a, this is minus tau, this is plus tau. Okay, so this is our signal xt pulse. Okay, so when we evaluate the Fourier transform of this signal, we will have this 2a tau. Okay, 2a tau sync omega tau, correct. Sync omega tau, correct. We will have this one. Okay, so you can see that 2a tau sync omega tau, sin omega tau means sync omega tau. Okay, so we have 2a tau sync omega tau, correct. Okay, so this is our signal 2a tau sync omega tau. So if we draw this signal, okay, draw the signal, we can see that here the amplitude is 2a tau. Okay, and it is like this. Okay, so you can see that at omega tau is equal to 5. Okay, at omega tau is equal to 5. Okay, this omega tau is equal to 5. Okay, we have this cosine. Okay, so cosine is tau, omega is equal to 5 by tau, no? So here it is 5 by tau. This is minus and it is plus 5 by tau, correct. This is sin omega and this is x omega, correct. So this rectangular pulse, we have this kind of frequency spectrum, correct. Okay, now we have, now we know the duality property. Okay, now we know the duality property. What is duality property? If we have a signal xt, Fourier transform is x omega, and if we have capital Xt, time domain signal, and the Fourier transformation will be 2 phi x minus omega. Okay, so we know this one also. Okay. Okay. Now we are given a time domain signal. Okay, time domain signal. It is say it is yt. Okay, yt as a sine omega naught t. Okay, sinc omega naught t. Okay, so this is my time domain signal. Okay, so if I draw this time domain signal, how it look like? Okay, how it look like? So same way we can draw this signal. So it is with respect to t. Okay, correct? It is with respect to t. Okay, I'm going to draw this signal. Okay, I'm going to draw this signal. Okay, so it is a sinc wave, and here it is t, and we have yt here. Okay, so you can see that amplitude is a. Okay, and it is omega naught t. So omega naught t is equal to 5. Okay, you will have 0. That means t. Now it is t, no, t domain. So t should be equal to 5 by omega naught. Okay, so here this t is equal to 5 by omega naught, and here also 5 by omega naught. Okay, correct? 5 by omega naught, this will be 0, and you will have the 0 point cosine point like this decaying signal. Okay, okay, so this is a, this is 5 by omega naught, 5 by omega naught, correct? So this is our signal now. Okay, now this is our time domain signal, and we are asked to find the Fourier transform. Okay, we are asked to find the Fourier transform of this signal. Okay, so we have to find this one. Okay, so you know that if we have a rectangular pulse as a Fourier transform, we will have sinc pulse. Okay, so now if we have a sinc pulse, okay, by duality property, okay, we will have 2 phi by x omega, x minus omega. That means this xt should be replaced by x minus omega. Okay, okay, so you can see that. Okay, so we can use this fact. Okay, actually we can use this fact. Okay, so you can, so what you have to do is you have to form this signal with respect to our given signal. Okay, so you have formed this signal, this 2a tau sine sinc omega tau, as in this. Okay, as in this. Okay, so you can see that 2a tau, okay, 2a tau, 2a tau is there. Okay, so I can use here. Now you can see that this tau is a constant. Okay, this is a constant. Okay, and this omega is the variable. Okay, this omega is the variable. This tau is a constant and omega is a variable. Okay, now you can see that this omega naught is the constant. Okay, and t is the variable. Okay, so this omega naught we have to use as this tau. Okay, coefficients. Can you understand it? Okay, so this tau is identical to omega naught here. This omega is identical to t here. Okay, so I think it is better to write this in this way, tau omega. Okay, this tau is the constant. Okay, so instead of omega tau, I will write it tau omega. Okay, understand? Okay, so you can see that this omega is a variable, okay, and this tau is the constant, okay. And here you can see that t is the variable, omega naught is the constant. So this omega naught is identical to tau here. This omega is identical to t here. Okay. Okay. So if I form this signal in this way, because this signal we know the Fourier transform. Okay. So this signal in this way, we will have here 2 is there. So I put 2 A. A means the amplitude, tau is this coefficients, no? Here it is the angular velocity. Here and here it is the angular velocity. So it is omega naught, okay, sine sinc omega naught t, okay. And here I put 2a omega naught, okay. So I have to divide it by 2 omega naught, okay, correct? Okay. So I can form this signal like this, okay. So now our yt have, so now our yt is equal to 1 by 2 omega naught 2a omega naught sinc omega naught t, correct? Okay. So we have this signal, no? Here we can see this signal. This signal and this signal is very much identical. Instead of tau, here it is omega naught. Instead of omega, here it is t. That is the only difference. This one, this signal and this signal, same, no? This signal and this signal, same. Okay, instead of tau, here omega naught is there. Instead of omega, here t is there. Now you can see that this signal is converted to a time domain signal, no? This omega, the frequency domain signal converted to a time domain signal. So we just replace this omega by t. Okay, we just replace this omega by t. Okay, so we form this signal. So you can see we can use the duality property. Okay. So now we have, okay, now we have, I write it identical to duality property. Here xt, x omega. Okay. Now x omega should be 2 phi x minus omega. Okay. For xt, we have a rect tau by 2 tau. Okay. Correct. This is we have. Okay. And for frequency domain signal, we have 2a tau sinc tau omega. Okay. And instead of omega, we have here 2a omega naught sinc omega naught t. Okay. So you can see that here tau. Okay. You can hear that this is tau is a constant. And here omega naught is the constant. So tau is identical to omega naught. Tau is identical to omega naught. And this omega is a variable. Okay, here the independent variable is omega. And here the t is the independent variable. Okay, so now we have replaced this omega with time. Okay, so we have 2a omega naught here. Instead of this tau, we have omega naught again here. Okay, 2a omega naught sine omega naught. So this symbol we have, but it should be divided by 2a, sorry, 2 omega naught, correct? It is divided by 2 omega naught, correct? Okay. Okay. So this is our yt, no? So this signal is yt, correct? This 2 omega naught and 2 omega naught cancelled out. So you have a sinc omega naught t. That is our signal, no? A sinc omega naught t, correct? Okay. So you can see that uh, yes, because I divided it by 2 omega naught, our given signal is we are given to find the Fourier transform of this signal, no? A sinc omega naught t. Okay, this signal sinc. Okay, this is sinc. Sorry, I always write it as sign. Okay, but this is sinc omega naught t. Okay, so we have this signal. No, we have this signal to evaluate Fourier transform. So we can say that this is, we can't evaluate this directly. Okay, so we have to use the duality property. Okay, so to use the duality property, we should have we sh, uh, we should have the Fourier transform of uh, rectangular pulse. No, so here for rectangular pulse, for this rectangular pulse, a rect t by 2 tau, we have 2a tau sine tau omega. Okay, so this rectangular pulse we have 2a tau sine t omega, tau omega. Okay, so this is our sinc function. It is in omega domain. Okay, now we want to evaluate. Okay, we want to evaluate a sin omega naught t. No, okay. So this is the non-signal. Okay, and this is the signal we have to evaluate. Okay, so to use the duality property, I should have this signal same as this signal. Okay, මේ signal එක වගේම මේ signal එක තියෙන්න ඕන. Understand? This signal and this signal should be identical. Okay, so I want to form this signal exactly as this one. Okay, so you can see here we have 2a tau. Okay, we have here 2a tau. We have here 2a tau. Okay, 2a tau sinc tau omega. Okay, so we have know that this tau is very much identical to omega naught, and this omega is identical to t. Okay, so we have sinc omega t. Okay, so this part is already there, no problem. Okay, so we no need to do this part anything because this part is already there, sinc omega naught t. So this part and this part identical, but we need this part also to directly use this function. Okay, because this function transform, we have this to a tau sinc tau omega. Okay, so I have to put some 2a tau here. Okay, so we know that tau is identical to omega naught and a is the amplitude, so we have already a there. No, amplitude is there. Okay, or if it is b, it is okay. Okay, say it is b. Okay, and this a and b is identical. Okay, so I can use that amplitude here. Okay, a or b or something. Okay, so given amplitude. Okay, if our signal amplitude, the given signal amplitude is b. Okay, it is all right, b should be there. Okay, and it is identical to a. Okay, but here we have 2 tau another value, no, 2 tau. So for that 2 tau we have to already also put the 2 tau here. Okay, but we can't put 2 tau here because the tau is not in this signal. No, given signal we don't have tau. Okay, so we have to get the coefficients with our signal, given signal. So identical to tau here we have omega naught, so I put here omega naught. Okay, So we have additional 2 omega naught here. Okay, so that is not the given signal. No, we have only given B sin omega tau. Here there is no 2 omega naught. So to get our original signal, again I have to divide it by 2 omega naught. Okay, so I have the signal very much identical to this one. Okay, did you get the point? Ahmad? Okay, thank you. Okay. Anyway, most of you understanding is okay. Okay. So it is very easy to proceed. Okay. Because in some class, I can see that the understanding of this subject is very less. But with you guys, most of you have a good understanding about this subject. Okay. That is why actually I take so long to teach you. Okay, it is very interesting for me actually. Okay, to do this lecture with you guys. Okay, so you can see that we have make our signal very much identical to this. Okay, so we have 2a tau sinc t tau. Instead, we have 2a omega naught sinc omega t. Okay, so we have to put the Fourier series conversion here. Okay, so we have a rect tau by, sorry, t by 2 tau. Okay, so also, so here I can use the duality property, and I can use directly as 25x minus t. Okay, minus omega, sorry. Okay, so this t should be replaced with minus omega. So I can replace it. Okay, so I can replace it. Okay, so I replace it to 5x minus omega. So x is a rect t by 2 tau. Okay, so xt is a rect t by 2 tau. Okay, so instead of this t, I have to put omega naught, sorry, minus omega. Okay, so here to 5 I have rect. Okay, omega, instead of this t, I have put minus omega and divided, and I have 2 tau, but this tau is identical to omega naught here. So I have to put it is 2 omega naught, correct? Okay, so we have 2 5 rect minus omega 2 omega naught. Okay, so the amplitude is there, amplitude is a. Okay, and our signal also amplitude is a. Very well, if our signal amplitude is b, we should have to put b here. Okay, not a, but the given signal also a amplitude is a. Okay, so we can put a directly here. So we get this signal 25a rect minus omega 2 omega naught. Correct? Okay. So I will write that signal. Okay, I will write that signal. Okay. I will write the board signal again. Okay. So we have, okay, so we have uh, we have t, and we are given a pulse like this. Pulse amplitude is a. Okay, pulse amplitude is a. We have here we have minus tau. Here we have plus tau. That means the width is 2 tau. Okay, and our The frequency domain signal is Sinc signal like this. Okay. And here we have 2 5 tau. Okay. And here we have 5 tau minus 5 tau plus. Okay. This is the signal. And what is the given? So this is we have solved. Okay. And what is the next given signal? It is a Sinc signal. Okay. So if I draw this signal, okay, so it is a Sinc omega naught t. Can you remember? It is a Sinc omega naught t. So a, the amplitude is a, so it is like this. Okay, it is like this, a. Okay, and you can see that omega naught t is equal to 5. Okay, omega naught t is equal to 5. We have 0. Okay, so here we have 0. Omega naught t is equal to 5 means omega naught t is equal to 5 means 5 means uh, t is equal to 5 by omega naught. Okay, so here we have 5 by omega naught, and here we have 5 by omega naught. So our signal is like this. Okay. So now also you can see here it is omega, it is x omega. So you can see that omega we have t here, and instead of tau we have omega naught here. Okay, but here we have 2a tau. Okay, 2a tau, but here we have only a. Okay, so that is why I write multiplied it by 2 tau, but not tau, because tau is not here, 2 omega naught, and it should be divided by 2 omega naught. In this one cancel, we will have a again. Okay, so we have this signal. Okay, so if I find the Fourier transform, I have this one, no, 25a rect omega by 2 omega naught. Okay, so we have this signal. Okay, it is 25a, 25 is there. Okay, 25a rect omega by 2 omega naught minus, okay, here minus omega by 2 omega naught. Okay, so I will write the plus here. Okay, I will write the plus, I will draw the plus here. Okay, I will draw the plus here. So you can see that here the amplitude is 25a. Okay, amplitude is 25a, and the this is in omega domain. So because this is the independent variable, so this is in omega domain, and you can see that the pulse duration is 2 omega naught. So we can say that here it is minus omega naught and plus omega naught, and this is our pulse. Okay, okay. So likewise, we can get any signal spectrum. Okay. Okay. So you guys understand this. Okay. So again, I will I will do another one. Okay. So we are asked to find. We are given another signal. Okay. We are given another signal. That is, say this is ZT. So this is YT and Y omega. Okay. So this is YT. Okay. So this is YT and this is Y omega. Okay. So this way we have to find the spectrum. Okay, using the duality property always. Okay. So again, say that we have another signal, that is Y equal to no, B Sinc Sinc 5 by 5 by 2 T or something. Okay, so we are so here we will put some value here, 20 value. Okay, so we are given this kind of signal. Okay, and we are asked to find the Fourier transform. Okay, so can you guys do this? Can you have can you get 5 minutes and try to solve this? I have a meeting at 5 o'clock, but I will take some time, okay? Because otherwise it is not completed, okay? So can you take 1 or 2 minutes or 5 minutes and try to solve this one?